In this division, our partner is ETH. We are signing an agreement with them and starting some collaborative research projects in the near future. Then we have a division that deals with the production of ethanol and other products through several technologies. Partners there are Oxiteno and Dedini. We have already a number of projects we have been going on with those companies for the last 2 years, and we have a large number of projects which are funded solely by FAPESP. We also have a division on new processes in alcohol chemistry. Partner there is Braskem. Then we have a division on ethanol-based engine and fuel cell developments, and a fifth division on the economics of ethanol, ethanol production and the environment, social impacts, and the new agriculture of food and energy. For example, one of the projects that we fund in Division 5 is the project that contributed to ECONI for them to develop the Brazilian land use model and make the case to defend sugarcane from ethanol as an advanced biofuel in the EPA definition, such that now sugarcane ethanol is considered an advanced biofuel. Those are the companies which are partnering with us up to this moment. We select proposals. The company tells us a list of teams in which they are interested, and we publish a call for proposals in those teams. Researchers that want to contribute to those teams can submit a proposal. We make a selection together with the company, and the ones which are approved are funded by FAPESP and by the company. The BioEn research project program, as I mentioned to you, has 314 scientists at this moment. It's worth about 61 million in money from FAPESP, plus salaries of those 300 scientists, 229 from the state of São Paulo, 33 from other Brazilian states, 52 from other countries, mostly the United States, France, Germany, Netherlands, Denmark, and Spain. Some of the results that we have in the program, just to illustrate, we have many results, but one of them is this result which relates to a transgenic sugarcane, which could have up to 9 times more sucrose than the normal sugarcane. Our scientists found the genes they can work on to make the sugarcane much more sugar, to have much more sugar content than in normal cane. That's the object of a United States patent. That's done by the team of Professor Glaucia de Souza and several researchers. And you see, there is a number of academic institutions like the University of São Paulo, University of Campinas, but then there are research institutions that belong to the private sector like CTC. Then there is Monsanto, then there is Central de Álcool Lucélia. So it's a broad program that includes academic research and industrial research, companies, universities, research institutes. Another one of our results and objectives actually is to increase the productivity of sugarcane, because the way we look at advanced biofuels is very much in line with what Lynd just shown here. There is cellulosic biofuels. But for Brazil, we cannot think of cellulosic without considering first-generation ethanol, because the existence of first-generation ethanol in Brazil makes cellulosic ethanol much more productive, much more of a reality, because you are not starting out of zero production, but you are starting out of a large production of first-generation sugarcane ethanol. So actually you have 2 faucets in your mill. You have one which puts out ethanol which was made from sugar with first-generation technology, and a second faucet that will put out ethanol made from cellulosic technology. And then you have to optimize the interplay between the 2 of them. You cannot think of cellulosic alone by itself in Brazilian technology. In other countries in which you cannot have first-generation ethanol, then cellulosic exists per se. But in Brazil, cellulosic will exist together with first generation. So one of the important challenges is to increase the productivity of sugarcane. We are now at around 84 tons per hectare. we would like to go to this, which is the maximum verified commercial case in the world, and then maybe up to 212. We don't think we will be able to get to 380, which would be the maximum theoretical possibility for sugarcane, if you could use all the sun, all the water, and have perfect balance of all the molecules and chemical reactions in the plant. Sugarcane research is intense in São Paulo and in Brazil. The number of scientific papers produced in sugarcane is higher in Brazil and in São Paulo than in any other country around the world. So there is a lot of accumulated knowledge. If we want to really compete, we need to keep on accumulating that and, more important, convert that into applications, into development of the biofuel industry in Brazil. And some of those challenges, and I will conclude with this slide, are increasing productivity. There are two basic words here, productivity and sustainability. Increasing productivity, we want to increase biomass production. We want to add process to our first generation systems. We want to work on the use of cellulose and to study and understand how is that you can have an interplay between producing electricity and producing cellulosic ethanol, much in line with what, again, Lynd has just shown. We have a number of researchers doing this kind of simulations and modeling of this interplay. And then there is an essential word for Brazilian ethanol, which is sustainability. All world standards will include sustainability as a very, very important part of the decision. So we need to have good work in Brazil about emissions, about land use change, indirect land use change, the use of nitrogen. We need to improve our processes in terms of water use. We have a number of researchers and research projects dealing with that. For example, our researchers know which genes in the sugarcane genome are responsible for reducing water use by the plant. Now we would need to learn how to control those genes to make a sugarcane that will use less water and produce the same amount of sugar or even more sugar by using less water. We need to understand the interplay between agriculture for food and for energy, the environmental impacts and the social impact. So, in conclusion, the São Paulo Research Foundation is developing this program, which is BioN. We have already a large number of research projects there. We involve more than 300 scientists, and we are open to new proposals, new opportunities, because our belief is that if Brazil wants to keep its leadership in the biofuel industry in the world, we need to add a lot of research, a lot of science to what we are doing here in this country in terms of biofuels. Thank you.
Okay, so I think that I will speak in English now in order to make easier the debate. So I thank my presenters again for the presentation, for giving us all this information and sticking to the time. We have to finish this room at 4 o'clock, okay? So I will ask my presenters to answer to the question as rapid as possible. And also I ask the audience to make short questions and, if possible, easy questions, okay? So I will begin speaking because I like a lot to speak, and there is no one else asking me to stop. So I will begin dividing the presenters in two blocks, let's say so. These three guys, they spoke more about the technique, about the technology, and Michael and Brito Cruz spoke about, let's say, public policy. Brito more on the scientific and Michael more on the complexity of producing biofuels. So starting with the technological guys, I saw that Guido showed us a very interesting approach that I can call capital light, so technology that can be put in practice using not so much investment and perhaps not so much operational cost. Then we saw Norberto showing us a very comprehensive solution with several steps on the pre-treatment and with the goal for integrating the second generation with the first generation. Guido didn't talk about integration. And then Lee showed us the results for his modeling, showing us how efficient, how feasible different approaches of integration we can have. So my first question would be, Guido, why don't you put in your presentation the idea of integration? And to Norberto, why did you are developing as such complex, let's say, with several steps on your presentation? So first, Guido, comment about the possible integration of your technology to first generation.
Well,
Som aqui, por favor.
See? Can be heard? Yeah, okay. I didn't speak about integration simply because most of the presentation we ran are for greenfield plants. But clearly we can use bagasse, we can use the cellulose and the hemicellulose which is in the bagasse and the lignin to be burned to recover energy. So the plant is clearly a bolt-in the first generation plant, and actually we're running tests with some operators here in Brazil to take the leftover leaves and the bagasse, to integrate that, use the bagasse to produce additional ethanol. Just want to say, I fully agree with the professor from Dartmouth University. The only difference is we're delivering now. We have a plant that can do the 40 cents a liter today.
Ok. Norberto, se você quiser comentar, pode ser em português. If you want to translate.
O pré-tratamento e o consumo e a eficiência das enzimas talvez seja para nós hoje o grande desafio para o amadurecimento da tecnologia. Sendo bem simplista e bem simples na análise, né, esse bagaço precisa chegar de uma maneira, as enzimas, e a gente tem que torcer pelas enzimas para que elas sejam eficientes, né, deve chegar de uma maneira que elas façam o trabalho delas. Né. Mas a gente está num mix do conhecimento que a gente teve desenvolvendo a tecnologia, um pré-tratamento ácido, né, e fazendo quase que um mix com pré-tratamento termomecânico, e essa sinergia de processos tem nos dado bons resultados. Estamos entusiasmados com os resultados.
Okay, so in the end, we have to be feasible. Okay, so we have different approaches for the pre-treatment, and including hydrolysis and simultaneous fermentation and hydrolysis that perhaps is not feasible in the first generation, because our process in the first generation used centrifuges to recycle the yeast, and when we put simultaneous fermentation, make impossible using the former technology. So, Lynd, would you please comment on this?
Yeah, I'd be happy to comment on that specific matter you brought up. Your fermenters are tiny. They're very small. You personally took me on a tour, and there was all this big equipment and boilers and whatnot and big, tall distillation columns, and in this tiny little corner of the plant was the fermenters, because you've got 8-hour reaction times with your cell recycle. So, first of all, your fermenters are already occupied. Secondly,